Good morning to all. I'm Mohan, Department of Mathematics, SNS College of Engineering. See, we discuss going to about the unifying vector calculus in a vector field in using the vector calculus, that Green's theorem, divergence, and the Stokes theorem. See, in these theorems is using to the jump arc of a journey through the core theorem, vector calculus, discover how these theorems connecting line integrals, surface integrals, and the volume integrals explore their wide ranging applications in physical and engineering. See here that very clearly that we know that Green's theorem, Gauss divergence theorem, and Stokes theorem, these and all the wonderful discover how the theorems connect line integral and surface integral. So that is a very important thing. Then also is known as explore their wide ranging applications in physics and engineering. That is very must to do that in the Gauss theorems. See here we are using the Green's theorem, circulation of flux in a plane. See, flux, there is a lot of we need that the flux here, that we have to do that. The Green's theorem connects a line integral around a closed surface, closed curve C to a double integral over the region D bounded by C. Then we have to do that formula of P dx plus Q dy is equal to double integral d of dou q by dou x minus dou p by dou y into dA. So here the Green's theorem to the integral around a closed surface, that Green's theorem that we are always using in the closed surface, then the circulation of flux in the plane. So here that P dx plus Q dy is equal to dou q by dou x minus dou p by dou y. Then here the application of Green's theorem, area calculation, fluid dynamics, and electromagnetism. See, area calculation using Green's theorem to find the area of a region D. So area of D, we know that always the closed surface of x dy or y dx. In this, regarding that the area of calculation x dy that or y dx, that will be using in the Green's theorem, its accurate given data. And the fluid dynamics. See, fluid dynamics is the very important thing in Green's theorem. Because of that Green's theorem, the related fluid flows around a closed curve to properties within the region, calculations and a flux. And the electromagnetism. See, in this electromagnetism to the related electric current to the magnetic field using Ampere law in magnetostatics, and the theorems offered a powerful tool for diverse scientific and engineering challenges. See here that the application of Green's theorem, that area of calculation and fluid dynamics and electromagnetism. See that here Gauss divergence theorem, flux across a closed surface. The divergence theorem links the flux, a vector field throughout a closed surface S, to the volume integral of the divergence over the region E closed by S. That double integral f vector dot ds is equal to triple integral that del dot f into dv. So here that the total outflow of a vector field from E equals to the integral of the source density over E. Then the divergence theorem links the flux of a vector field and then the volume integral of the divergence over the region E enclosed by S, then that F vector dot dr is equal to del dot F vector into d. Thank you.